We're standing in Oregon State University's Peavy Hall building, which is made out of CLT, cross-laminated timber. And this university chose to put in over 350 SMT sensors to show the performance monitoring of the building during construction, and obviously over the long term that it has a sustainable use. The sensors that were primarily used from SMT were string potentiometers that measured the movement or displacement longitudinally within the CLT. And this display here is for all students to come here and to learn more about what these sensors within the whole building are doing. Also placed here and subsequently in other areas are point moisture monitoring sensor. These sensors measure the moisture content of the wood itself and also the temperature within the wood. And what they do is they will send readings back to the A3 data logger, which will collect the data and then obviously send it back over the internet for live monitoring. We'll go into other parts of the building where we're going to see these sensors used within the 3-story shear wall of the stairwell that I am standing in. So here at the top of the shear wall, you'll see the post-tension cables have load cells that measure the amount of force that is placed on them, as well as the string potentiometers are there when the wall moves and it snaps back together. We can not only catch the movement itself, but also its final resting position. So in the case of an earthquake that may happen, within a few seconds, we want to be able to catch the movement and understand what happened to this wall over that time period. So ultimately, going forwards, we'll have data on this type of wall. As the primary researcher on this project said, there's been about 10 of these walls that have been installed worldwide, so still a net new improvement to using mass timber in this environment.